All right, so lesson 6, the wave mechanical model. So this is now trying to fix the solution, or trying to fix the problems that the previous model had, which was Bohr's model. Bohr's model accurately described that the electrons had to exist in set energy levels. De Broglie, along with Schrodinger, came up with this idea that maybe these electrons aren't so much just charged particles, but maybe they're waves acting in these circles. So here's a few different diagrams that you can kind of use to describe what's happening here. But I'm going to show you quickly one method of kind of imagining what these things may look like. All right, so this goes back doing a little bit of physics 20, and we're talking about standing waves. So if you remember, a standing wave is the idea that if you have a wave, one complete wave going up followed by down, something like this, it would almost look as if it was standing because it had constructive and destructive interference throughout. It would have what we consider to be a node position, and then we also have the anti-node in the middle. So these are all nodes. Node. This would be known as an anti-node. So this right here is one complete wave. We could also represent this as 2 waves, 3 waves, 4 waves. We're talking about full waves in this case. So if I were to draw the next one, maybe a little bit bigger, and just say, okay, this is one that has 3 complete wavelengths. So I'm going to draw this as 1, 2, 3 sections. I want to draw one complete wave in the first one, 1, followed by the second one, 2, and then one more, 3. Try to make them as even as possible. Oops. And I'll do my other color here and do the standing wave aspect. 1, 2, 3. Perfect. Okay. So here we have a bunch of nodes and antinodes. What I want you to try to imagine is that this is an electron kind of spread out as these probability waves. And what we're going to do is take that center black line and curve it into a circle. And when I do that, I curve it into a circle. Oops, that didn't work. Let's try that again. Circle, nice. Okay, so I took that black part and I bent it around so that this end here came in and touched with this end here, and we made a complete circle. So it turns out that if I were to look at this and try to figure out the nodes, antinodes that's going on in this case, I would say, well, there's 1, 2, 3, 4, 5, 6, 7, kind of. It turns out that this node, because it lines up with the first one, that there's only 6 nodes in this case. So I want to take my circle and try to break it up into 6 equal pieces. So here I have the top, and cut it in half, and then cut this into thirds. So I'm going to say about here, and about here, and about here, and about here. Let's make sure. 1, 2, 3, 4, 5, 6. Okay, perfect. And what we're going to try to do is we're trying to recreate this. So if you imagine that this is the outside of my circle and this is the inside, we can then try to imagine that whenever it's red going up, that means it's on the outside, and then when it's red going in or down, that's on the inside. So let's see if I can recreate this. Starting at the top, I'm going to say, well, my wave is going up like this one, and then down, and then up, and then down, then up, followed by down. And what you'll notice is this one is what I consider to be like the fidget spinner kind of pattern. And if I do the opposite, I end up getting with this cool kind of flower shape. And it turns out that since this is 3 complete waves, this would be the idea of the energy level for n equals 3. This would be the 3rd energy level. And you can imagine that if I were to take that first wave, just 1 complete wave, 2 complete waves, 5 complete waves, that these circles would get bigger and bigger and bigger. So this is kind of the idea of the wave mechanical model. that we're imagining that the electrons are no longer charged particles spinning around in a circle, but instead they're electrons existing as probability waves as they're zooming across these orbits. So once again, looking at this idea down below, Schrodinger described the electron as a three-dimensional wave function. You don't need to worry about that so much. The wave function has no physical meaning. There's this weird idea, the square of the amplitude, once again, not necessary for physics 30, but it resembles what we consider to be a cloud. So this is also known as the cloud model. And the benefit of this is that it takes away the idea that there should be constantly emitting EMR. So whenever a charged particle moves in a circle, we said it must be emitting EMR. No longer are these charged particles. Instead, this is a probability cloud of electrons existing in an orbit around the nucleus. Once again, extremely bizarre. This is that whole idea of quantum physics. If this is of interest to you, feel free to dive into YouTube, search up more about the quantum physics universe. It's really bizarre, really exciting stuff, but this is kind of the edge of what we need to know for the physics 30 concepts. There won't be any questions about the wave model on your quiz. There'll be a lot of questions completely on de Broglie's calculations for the wavelength.